In my last lecture, I talked about reproduction in general. I talked about Easter cycles, how different they are from menstrual cycles. I talked about the Easter cycle having 4 phases, if you remember. I talked about the phases being the period of proestrus, when the reproductive tract is getting ready to receive the fertilized ovum should mating occur. You get a thickening of the endothelium of the reproductive tract of the female. Then after proestrus, you get the period of estrus. And that's the only time that the female will allow the male to mate with her. She may seek the company of the males in the proestrus period, but it's only during the period of estrus itself that the female will allow the male to mate with her. Then after estrus, you get the period of metestrus, which is the cleaning up phase, if you like, if the animal is not cycling, if it's not pregnant, mating has occurred, but you get a sloughing of the endothelium, the lining of the uterus. You get an invasion of white blood cells, particularly into the vaginal epithelium. You get some sloughing there of the thickening that's occurred during the period of estrus. And then you get the period of diestrus, which is the resting phase, which can vary in length depending on the frequency of cycles. In some animals, like the dog, you just get 2 periods of the year when she's reproductively active, usually spring and autumn. Why that should be in evolutionary terms, I have no idea, but that's the way it is. And of course, the gestation length of the dog is 63 days, so the young are born 2 months after mating, so it's hard to see why it's tied into seasonality of the year. The other thing I didn't make clear the other day, thinking about animals that live in the tropics, where the daylight length is the same all year round. You don't get differences in daylight length. And the important thing to appreciate there is that it's probably availability of foodstuff, in other words, the nutritional state of the animal, to a large extent determines when the breeding season will be. If you take the example of axis deer, you know that deer, before the rutting season, grow their antlers. They grow them dramatically because after every breeding season, deer shed their antlers. Now, it's a very demanding nutritive exercise to grow these large antlers. So what's the point of shedding them? Because many species of animals grow antlers and they don't shed them. And of course, the answer is that if they're damaged during the rutting process, and that can often happen in these ferocious fights that you see on television and so on, if they're damaged, then the animal is not subject to carrying damage to the rest of the life and sheds them and grows them as a set. But if you take deer species, for example, that live in the tropics, axis deer, for example, that are found frequently in India, what happens there? Because the daylight is roughly the same all year round. And there's an inbuilt time clock. So if you look at a herd of axis deer, the males, some of them will be in hard antler. In other words, some will have grown antlers that have grown the velvet stage, which supports the growth of the antlers. They will then shed the velvet, and they'll be hard antler, ready to fight. But others will have shed their antlers and will be growing them. So you get deer in hard antler and soft antler at the same time. It's not to do with the daylight. And if you then transport those deer, for example, from India to a wildlife park, to a zoo in this part of the world, it's evident that there's an inbuilt time clock. If you go to Goodsnake, which is a wildlife park outside London, where they have axis deer, you see them there in hard antler and soft antler all the year round. We used to have them at Photo Wildlife Park, but we couldn't contain them. They're fantastic jumpers. We used to jump out of the wildlife park, raid the farmers' corn and so on, and then jump back into the wildlife park every morning. So we had a lot of problems, so we had to dispense with the axis deer. An 8-foot fence is no problem for an axis deer to see the feet of corn inside and get what they come. So that, and so to some extent, it's also the nutritional status of the animal that determines whether they breed or not. The other problem sometimes is if you see black swans, for example, natives of Australia, they appear there to breed at the time of the year, which is most like midsummer for their animals to signal to survive. But move a black swan from on a nest. We have them in the sea many times where the black swans hatch their cygnets in January, usually on February, usually in a snowstorm, and you would end up taking the cygnets in and carrying them. So they have a cycle that's stuck at a time of the year which they always breed, irrespective of daylight level. And the Syriopsis goose is another example of a goose that inhabits the southern hemisphere, which doesn't change. On the other hand, domestic, if you move horses, cattle, anything else, there's either long day breeders or short day breeders, move them from the north to the southern hemisphere. It's very obvious then. Daylight length controls that cycle because they change with the daylight lengths. And so it's just some particular animals that don't change as a good system. The other thing that I got around to discussing the other day with some former students, and that is, what is the reason for the great variety of gestation length? I mean, if you take, come to the right-hand side here, where you get bison, hippo, rhino, and elephant. Well, bison, hippo, and rhino are roughly the same size, particularly hippo and rhino. Why on earth would a rhino have a gestation length of 540 days and a hippo of 200 days? In other words, what determines gestation length? And it can't be, I mean, okay, the fetus is larger when it's born, and obviously more development has to take place in utero, but not a hippo has the same amount of development as a baby rhino. What is the reason for the difference? And I think that's all you can say back in the evolutionary tree. I mean, the other which Frank Giel always talks about is the hyrax, this extraordinary beastie who's very small breed animal, but whose ancestor is a donkey. And it has a gestation length virtually the same as a donkey, even though it's a small little animal. So it's to do with the ancestry, to do with the background as to what it's going to have in terms of its gestation length. And I mean, the lion and the tiger, as you can see, the big cats, roughly the same gestation length. And the bear has a long gestation length, even though the baby is tiny when it's born. And it's born, as you know, as I said to you, when the mother is in torpor in the winter, it's born very immature, and it attaches itself to the nipple, and then it feeds on the nipple and grows quite quickly. Giraffe is 455 days. Why is that much longer, for example, than a hippo or a rhino, or than a hippo? I don't know. Baby hippos, incidentally, have one absolutely fascinating ability. You try and hold your nose, can you swallow underwater? Hold your nose and try and swallow. Whereas hippos feed underwater. And I don't know how they can attach themselves to the mammary gland of the mother underwater and suckle like fury. They can, obviously they can, obviously. But I don't know how that adaptation. I mean, whales are the same, they feed underwater. A hippo is always fascinating by being able to do that. And then after suckling for a while, they would come up and there'd be a huge breathing exercise, pumping of air and so on. But no problem there. Right, breathing and swallowing. So why does the gestation length vary? I don't think anything to do with evolution history or research. And I talked to you again about some animals having one estrous cycle after the other until they're mated successfully, and they're known as polyestrous animals. And then you get animals that cycle at certain times of the year, like sheep and deer in the autumn. They're seasonally polyestrous unless they're mated. So they have a number of estrous cycles until successful mating occurs. And of course, lactation in many species inhibits the reproductive cycle. Certainly in the pig, it inhibits, so we're talking about farm animals, it inhibits the reproductive cycle. Whereas in horses and cattle, for example, it doesn't. Horses and cattle have a postpartum estrus. Within 4 or 5 days of giving birth, they'll be back in season. They'll be back in estrus and ready to mate. And again, the fertility of the postpartum estrus is normally quite high. So in the wild situation, mating occurs successfully at that time. And this means that if you have an animal like a wild horse family, you can see that the gestation length will ensure that the animal is pregnant for much of the time. The horse is 230 days gestation there, so it's pregnant for much of the year. And the cow is the same. The cow has a most part just shortens, slightly shorter gestation there. But again, we're making a normal situation, not in a managed situation, and will conceive shortly after giving birth at those parties. So there are a whole number of factors that affect the reproductive cycle, but perhaps I forgot to mention that some species don't ovulate until mating is occurred. They're known as induced ovulators. And the classic example of this, those of you who domestic cat will know that she comes into estrus and will howl and meow until she's actually sent out to mate with the tongue. Very distressing for many owners, but that's the way it is. She's an induced ovulator. The rabbit is the same. Before I really understood enough about rabbit reproduction, I used to know that if I wanted to have a litter of baby rabbits, I took my pet baby rabbit to the vet, and she mated almost straight away because she's in estrus until she's mated. It was the actual act of mating that induced ovulation to occur. And what the advantages of that in evolutionary terms are to see, except that because normally animals live in groups and colonies and warrens, and there's always males present. So why would the female have the advantage of being heat until she's mated, being in estrus until she's mated? Hard to understand. That is the situation. And of course they talk about breeding like rabbits. When rabbits would breed, as soon as they have a litter of babies, they would get stuck in estrus again, and they would mate straight away again. And rabbits would breed all year round, because of course they burrow as well as protected from babies and the weather and so on. One other thing that we tell you, myxomatosis is something that you haven't experienced, the rapid myxomatosis in wild rabbits, the viral disease of rabbits. And they couldn't understand for a long time why, if you collected a rabbit in Europe and you brought it out to Australia and you wanted to let an infected rabbit loose because you wanted to control the rabbit population by using myxomatosis, people could see the ravages of myxomatosis. The viral disease spreads rapidly in rabbit populations. Why if you brought an animal out to Australia, or indeed onto some of the offshore islands in Ireland as well, down the island, whenever Lord Revelstoke talked to me about why he got a mixy rabbit, he wanted to reduce the rabbit population on Lambay Island. It's not symptomatic because the method of transmission is not understood. It's the rabbit flea that transmits myxomatosis. And of course rabbit fleas thrive in burrows. And if you introduce a rabbit into an area, because some rabbits don't live in burrows. If you get rabbits that live in very rocky ground where they can't burrow, they tend to just live in cover and not always in the same place, just in the scrub. And unless you have a rabbit flea population, you won't expect myxomatosis. So that was the reason why attempts to introduce myxomatosis onto some of the offshore islands now. So you get induced ovulation. I talked about diapause, what the advantages of diapause were. I really don't understand, particularly when the male and females are present all the year round. I can well understand, as I said, through examples of seals where the males and females are only present together for a short period of time. And the other interesting thing is, there's not diapause, but that some bat species mate before they hibernate in the autumn. And fertilization doesn't occur. What happens in those bat species is that the spermatozoa remains viable. The female being attracted to that, the entire hibernation period. And then, when hibernation ceases and an activity starts again, the spermatozoa are still viable, and when the female gets sufficient food, she ovulates in spring, then fertilization occurs. So that's not diapause. Diapause is where you get an inhibition of the development of the fetus. So in particular rat species, this doesn't happen. What on earth is the advantage of that? Everybody knows. And don't get the idea that we looked at a bird who was at the track the other day in the lab. When birds mate, the spermatozoa is obviously introduced to wake up and find its way up the oviduct of the fallopian tubes. But they can remain viable if the spermatozoa in the female reproductive tract for 48 or 72 hours, depending on the species. So there's a pool of spermatozoa there to fertilize the eggs as they are
So that it's not necessary to have mating to occur every day before ovulation occurs. Remember I said to you that a hen or a bird we usually one egg a day. So it's not necessary for fertilization to occur every day. Mating, they can store five spermatozoa for a number of days and they will fertilize the ova and they'll release from the ova.
And again, there are many other factors affecting the estrous cycle, the nutritional state of the animal. I mean, animals that are starving or work very hard, as I said to you, don't normally cycle very well. And I talked about pregnancy diagnosis. We could, of course, look at the hormones. That was the traditional way of doing it. You collect blood samples, and by looking at hormones in the blood, you can establish whether the animal is pregnant or not. You can use ultrasound, you can look at the abdominal contents of the animal, and you can visualize the uterus, and you can see the embryo growing, planting and growing the embryo. And of course, you can also manually palpate female reproduce that contracting the farm animals, certainly, and that's what they'll do to determine that. And of course, nowadays, the biochemistry development techniques for measuring hormones in fecal samples. And the reason why they know all the relevant to zoo or pregnant is because we take a fecal sample to measure the progesterone levels, and they know what the levels are if they have this pregnant or if the cycle follows. And again, I mentioned to you that in a group of animals, the rhino particularly using the fecal color beads to pick the speakers. So when you collect a fecal sample, you know what sample you're collecting. The alternative to get people to stand for hours and rush out to try and collect the samples of this animal. Some animals like elephants and rhinos are dangerous. You can't just rush out. If you try and get them in, when you want to get them in, because somebody watches the fecal sample, the rhino will always find some reason for not coming in. So Murphy's Law often difficult situation. Now, when pregnancy is established, some animals that normally have single offspring sometimes have twins. And of course, in some farm animals, you're always trying to promote the production of twins or triplets. If you take sheep, for example, the whole economics of sheep, management of sheep, is that if you can have twins or triplets or more, you've obviously got more lambs to sell. And certainly the ewe, well managed, more than capable of producing enough milk to feed to youngsters. But some animals traditionally only have single offspring, horses particularly, because of course the horse is born well advanced. And if you have twins in the horse, they're much smaller, and nobody, if you're breeding thoroughbreds or even pet animals, sometimes wants a smaller species. The same with cattle. If you've got twins in a cow, the calves are much smaller than the normal single one, which you expect to get in cattle, of course. So they're not promoted. And of course, it's genetic selection. You can genetically select sheep. You can manage a sheep flock. You can genetically select replacements from those animals that frequently have twins or triplets. And that gene certainly can. And that's just a simple matter of record keeping genetic selection to do that. Now, at the end of the period of gestation, of course, parturition, the animal has to give birth, has to expel the fetus from the center, from its uterus, living in its body. How does this happen? What's the trigger for the start of the whole process of giving birth? We have these various gestation nets. But what's the trigger mechanism that starts the whole mechanism of expulsion of the mature fetus from the uterus? Not clear. Almost certainly genetic. It's the size of the fetus, could be the length of time as well. But both factors are involved in determining when an animal is getting ready to give birth. So the signs of the approaching parturition are different. And again, an experienced stockman knows that animals will know what the signs are. For example, if you're talking to a man manages a dairy herd, or obviously production of calves is very important to secure the ongoing milk supply. The cowman will always talk about the cow being down on her pigs. What he means by that is you get a relaxation of the sacral, say, ligaments, which actually are around the pelvis, both
tail go up along the back, and the parts of the pelvis stick out there. And as the cow approaches the time when she's going to give birth, you get the reaction of the relaxation of the ligaments in the pelvic area. And you also get, of course, mammary development. The other begins to develop, because this is what the baby is going to have to fed on. So under the influence of the hormones, prolactin in particular, which is rising towards the end of the gestation, you get other development. So a good stockman who knows animals will be aware of the changes that take place. And even in giraffe and on some of the bigger zoo animals that you see, you can, a good person's experience looking at these sort of animals can determine when a parturition is imminent. And of course, it's obvious that other is the thing which happens. And people who breed horses who fuss like fury when the mare gives birth, because sometimes these foals can be extremely valuable. I mean, some of the foaling boxes, the facilities in foaling boxes are probably far superior in some of the studs that would be present in the rotunda or the hospital on the road. There's so much money involved. The groom would have a bedroom beside the foaling box. He would have television cameras. He would have alarms. So he actually, he's dozing, and the mare starts to shuffle around, the alarm will go. The mare is under constant supervision because they're extremely worried that if the mare should be desistance, that the group experienced group is allergic to this fact. I sometimes look at these situations and wonder what some of the maternity hospitals would say if they saw all these changes that actually take place. So this huge effort goes into making sure that the mare calves produces their foals successfully with all the alarms under the sun. So that's what happens. And again, in horses, you'll often hear about people breeding horses talking about the waxing of the teats of the mare. So you get some udder development, and within 24 hours of her giving birth, she starts to produce colostrum. Now, colostrum is a type of milk that's much darker in colour than normal milk, and it contains a huge amount of antibodies, because when an animal, a mare or a cow, lives on a farm, it produces antibodies to infection. And the colostrum is the first milk that the animal will suck, the developing neonate will suck from the udder. So the colostrum is extremely important because it contains antibodies. And it's strange, but these are big globular molecules. And in utero, the animal has very little exposure to this transfer of resistance from the mother. Okay, the mother has blood supply, and in the blood of that animal, the mother circles the antibodies which the disease was exposed to. But the neonate doesn't have any access to that. It's not till the colostrum first milk in the udder that contains the antibodies. And it's also been shown by characteristically that the digestive tract of the neonate is capable of absorbing these molecules only in the first 24 hours of life. So it's extremely important that animals suckle within the first 24 hours. And indeed, good husbandry systems in cattle, particularly sometimes in sheep, goats, or horses, if they actually will milk or take milk from the udder during the colostrum phase, and they will freeze it, particularly dairy cows, so that they have a supply of colostrum. Sometimes in the dairy cow, if you're taking the calf away from the mother before it actually gets suckled at all, you want to bottle feed it or bottle feed it right from the start. You're going to make absolutely sure that it gets colostrum, and they will have colostrum in a bottle, which they will feed the calf first thing before they ever get anything else. And that will make sure that the calf has some resistance to some of the incoming diseases. So what are the stages of labor? Well, when the gestation period is up, the fetal size will reach a certain level. The hormones change slightly, and you get some. Of course, there are placental hormones that I talked to you about the other day, and it's the placental hormones that take over for most animals in the later stages of pregnancy. And of course, it's the placental hormone, luteinizing hormone, that is the basis of the human pregnancy test, because again, the placenta is formed very early in the pregnant primate, and it's the human chorionic gonadotrophin that's picked up, and the pregnancy test works on that. I remember wondering why one of our female gorillas who was living with her brother was getting overweight. I was saying to the pregnancy, you stop feeding her. You're feeding her too much. I started weighing her. So we kept weighing her, and her weight was going up. I said, oh dear, I wonder. And I said, stores can't get a human pregnancy test kit for those chemists. Just checked the urine sample, and then she was pregnant. But she was pregnant with her brother, so that wasn't a very good recommendation. And of course, no activity had been observed by the fetus control. So it was a misaligned in a big way. Anyway, she went on to give birth successfully, and the animal was pampered. She had never been brought up to a mother. There was a school in Russia, and she wanted to do this thing. I remember as I read the CSO, I actually gave birth to so many 5 pound legs. And that's not the way in which she should. You have to teach them how to look after the youngsters by making sure they're present and experienced mothers are giving birth, and then they will up to that. But anyway, what happens in the gestation is that you begin to get contractions of the uterus. And the first stage of labour is gentle contractions of the uterus, which actually are dilating the cervix. So that's the first stage of labour. And so you get dilation of the cervix. The second stage of labour is much more powerful contractions. When the cervix is dilated, you get much more powerful contractions taking place, which is pushing the fetus towards the cervix and towards the vagina and out to the outside of the anus. And of course, animals with long legs, particularly, are born with their feet first, followed by their nose. And it's quite amazing how it happens, but it always happens. In wild animals, it always happens that you get the feet coming first, followed by the nose. And then the contractions increase in intensity, and towards the latter stage of the second stage of labour, you get abdominal contractions as well. The combination of both expel the fetus to the outside. Now, they can last a different length of time. I mean, in some animals which are giving birth for the first time, the first stage of labour can last 24 hours. Very distressing for owners of dogs, for example, particularly when I experienced with creatures giving birth, where the dog is restless or uneasy for a full 24 hours. But all animals are restless during the first stage of labour. And then as the contractions intensity increase, the animal gets more and more restless. You get some discharge. In primates, you get and some other animals, you get the amniotic sac being produced, which is the amniotic sac with a lot of fluid. Because don't forget, when a fetus is developing in utero, the mother is doing most things. It's producing the lung function, as I talked about. The heart's obviously circulating, and I talked about the changes that take place in birth, but the lungs are not functioning. But actually, the kidneys start to, there is some urination taking place in the last third of pregnancy. And that fluid, the urine, is actually added to the amniotic sac. It's a way of getting rid of some of the toxic products of the whole development process. So the amniotic sac is produced, the waters is the way people like to call it, of the water first, as they appear. And then it's followed by the expulsion of the fetus. And then the third stage of labour, which is critical, is the actual expulsion of the placenta. Because it's very important to get rid of this massive material that's been supporting the animal and producing the hormones and so on, growth, the eventual gestation. It's interesting. There's a huge variation in susceptibility to infection postpartum. If you're a horse breeder, you will know that you have a large placenta. But unless that placenta is delivered or is expulsed within a few hours of giving birth, the horse is likely to end up with an infection, because you get dead necrotic material from the placenta that hasn't come away. And horses are extremely susceptible to serious disease. You get an inflammation in the uterus called detritus, and they're extremely susceptible to infections. They will succumb very quickly to fatal detritus if that happens. On the other hand, cattle. Now, I'm trying to go into the various different types of classifications or dislikes about the placenta, but cattle are incredibly resistant to retained placentas, placentas that don't come away. I mean, a horse breeder will make very sure that after the foal is born, particularly if it's managed in a foaling box or what over that, will make sure that the whole placenta has been reduced. There's nothing left inside the uterus of the female. Cattle, on the other hand, are incredibly resistant jobs effect can ever be asked to do, I think, is to go along and to remove or retain the center. You'd be used full of rotting necrotic material. And I can tell you, no matter how many protective clothing you wear, if you put your arm into a rotting, necrotic, stinking beetle like that, you don't get into that stuff today. I'll tell you what my wife used to say when she knew where I clean. It's not what I love, but they're incredibly resistant. Pigs are incredibly resistant, although having a whole number of milks at one time, they don't. They're very resistant. Dogs and cats don't seem to have any problem retaining the placenta or passed out after each youngster is born. So you get a pup or a kitten being born, and the placenta comes with a thing. There's an amniotic sac, of course, which has to be broken around the female. And then, and of course, the umbilical cord normally is severed, not deliberately by normally by the movement or the struggles of the animal. The mother doesn't necessarily go down and strictly fight the umbilical cord. The only other animal that I used to find privileged watching you doing was the giraffe that stands. I think I said this before. The giraffe gets thrashed on the concrete floor normally in captivity. But I mean, the giraffe is also amazing that the wild animals, what happens in the wild when a giraffe is going to give birth? She moves away from the rest of the herd. She seeks peace and quiet. She has to make sure that there are no predators following her. So she can actually stop. Most animals, once they get into the stage of labor, they can't inhibit themselves. But giraffes certainly can stop the whole process if they think it's a predator or something unusual happening. So they can stop and stop. Now, what the control mechanism is, of course, it's oxytocin from the posterior pituitary that really brings about the contractions of the uterus to expel the fetus. And it's oxytocin which is used to assist parturition in the animals and as well in small doses. But how the giraffe can interfere with that mechanism and then stop it again, not very clear. But it's also very clear that in order to maximize the uterine contractility of the uterine muscles, that the placenta starts to produce estrogens, because estrogens certainly sensitize the uterine muscle to the action of oxytocin. So if you get an old animal, I have to remember spending half the night trying to get a salad. This is a salad money to a widow, and she really shouldn't have been at all. The widow was short of money, so she couldn't eat pig. And the uterine inertia, the animal was so old, she simply couldn't expel it. There was just no uterine function there. So I was injecting oxytocin. I was there half the night, and my boss, who was very experienced, said, "Give her a shot of estrogens." And sometimes I had that, certainly, when I gave her an injection of estrogens intravenously, and then used oxytocin, I got a much better production. And we had 14 piglets at the end of a very long night, and a small bit. I remember it was 22. I just thought to myself, well, it must be easy the way this running 20 pounds. I crouched in a saddle outside. Stuff, but anyway, there we are. So that's what happens. And of course, if you look at talking to sheep farmers and so on, where you get more than one lamb being produced at one time. And why I talked about batch mating and having all the sheep giving birth at the same time, because you synchronize it, is that with the number of youngsters coming, they often need assistance, because when a sheep is yearning, when she's in labor, you very often find that it isn't one lamb coming together. What happens is, I said, they're normally going feet first with the nose behind them. What happens is that a foot of one, a foot of another tries to come at the same time, and it simply isn't running. So the experience, when you get an experienced farmer or any vet who's trying to sort out what's happening, you have to put your hand into the feel what's coming. And you can extract gently pulling, but you've got to make sure you're pulling the two legs and those of the same animal. Otherwise, you're going to jam up and fit together. And it's the same. I remember a difficult calving case that I was dealing with in practice, and I spent a long time trying to get. I could see a foot, a nose. I couldn't understand why I couldn't find the other leg. I put my hand in for a long time, waited patiently. Put my hand in again, had twins, because I didn't have ultrasound, I check what was there. But there was one leg of one, and the other leg was tangled in the other calf. So you've got to sort out those manipulations. And I was privileged on one occasion with small animals like bitches, like where you can't get the hand in. The old practitioners, of course, what you do now, if there's a problem with delivery, you simply give the animal anesthetic and you do a cesarean. You simply go into the abdominal cavity, do the whole usually you deliver the extra surgery. But in the old days, I saw Ham Lambert, a very famous double practitioner, who was absolutely deadly with the forceps delivery of dogs and cats, little tiny forceps. He would introduce them through the vagina into the reproductive tract, and using his hands to manipulate the youngster through the abdominal wall. He seemed to be able to always position the forceps very gently onto the foot of the head of the top of the kitten, and very gently draw it out. Very gentle pulling, you have to assist. I also had an alarming experience back in the day where I went into the cow, and as I got closer to the arm, I saw a truck through the rope. They'd actually attached a rope onto the foot of the cow and were pulling it with the truck. Horrific. Now, this is now getting to veterinary obstetrics to do with this stuff, but I mean, the pelvis of the cow is deeper that way than it is wide. And if you get a calf that's stuck, you rotate the calf, you twist the calf, so it comes out of the pelvis in the long axis. But of course, they hadn't waited for me to get there. They said, we got to have to give this calf a pull, so they attached the tractor and started to pull. So I just turned around in the yard and I said, that's not for me, good luck, lads, and I went away, because I wasn't going to get it. The only solution to that, if it's hip lock, is to shoot the calf. I mean, you try a cesarean, but you can't get it back either. So, I mean, my boss had to go out and get very cross with the cow guy, but I refused to get it on. I mean, that's just ignorance, because even there are things called calving jacks, which you have to gently propel. But that means if you're a single practitioner, you put ropes on both feet, and you hydraulically jack them very, very gently. And you make sure that everything's happening very gently. And in sheep and cattle, you use lots of lubricant, glycerines and so on, to make sure there's nothing jams anywhere, and you can twist the animal to make sure that the long axis of the pelvis and so on. But that's veterinary obstetrics, and I'm not going to teach you that. I don't have time to go through the various types of placentas that are produced, but the hormones of the placenta are very important. I talked to you about the human chorionic gonadotrophin, which is the basis of the human pregnancy test. Works in primates, but it works in chimps and gorillas. Doesn't work in orangutans. They're destroyed with PCs. That's another story. But you also get estrogens produced by the placenta, and the estrogens rise towards the end of the gestation length to sensitize the uterine muscle to the hormones that are needed to get them to contract. Progesterone is produced by the placenta, of course, as well as by the corpus luteum of the ovary. That's what interferes with the cycle. That makes sure that the whole female reproductive tract doesn't go through a cycle. It's quiescent during the period of pregnancy. And also, towards the end of the gestation period, you get a hormone called relaxin produced. Relaxin is what they make taper relax, which makes sure that the vagina and the vulva can expand to accommodate the fetus as it push through. And obviously, they're important. But the other thing that I don't know the answer to, I don't believe anybody knows the answer to, when you think about a fetus, it has foreign DNA in there from the male. Why doesn't the female reject that? Well, obviously it doesn't, because it was what we would call it here. But it's not understood why it's not. They talk about hormones. Every so often there's a publication that talks about hormones, talks about some way, how does the fetus hide from its mother? And I suspect there's a common link here with some parasites. How do parasites hide from the defense mechanism? Foreign material is living either in the intestine or getting from the teeth. So you get some antibody reaction, we better talk a little bit about that. But I'm not sure that that's an area that's understood at all. It's a bit like saying that animals don't digest cells, there's lots of uses around that. I don't understand that. I don't understand why half a developing embryo has genes that should come up, material that should be foreign to it, yet it's not rejected. I don't know what that is. I don't know whether there are hormones in the placenta or whatever.
Now, for those of you who'd like to, the textbooks that I mentioned are rather light on some of this veterinary work, and there's a textbook I'd like, because if anybody wants to read a little bit more about this, there's a textbook by Bronson, B-R-O-N-S-O-N, Mammalian Reproductive Biology. It's in the Hamilton on Open Access, as far as I know. It's, remember, it's starting 5.99, N.99. If you wanted to read a little bit more about animal reproduction, that's what I would recommend. You to do the textbooks that I recommend are very human-oriented. Okay, I hope that this is my last formal lecture with you, so I hope that I've tried to give you some indication of some extraordinary and fascinating physiological parameters that animals have adapted over the world evolution, enabling them to have a particular niche. I hope that you've got some idea about that. I mean, I was very distressed last year when a student came up to me after this series of comparative stories with lectures and said, what's the point? You mentioned how animals work. Surely you would have recognized it about the water about the jelly. And I don't think I really got to that students at all. The marks they got in their exams were pretty frightful. Anyway, they're entitled to their view. It's like when I was a final year veterinary student and the professor said to me he was a parasitologist, did you enjoy my course in parasitology? And I said, no, it was irrelevant. I have very strong views about why it was irrelevant. It was taught systemically. People that diagram about the cow often say these are the parasites of the cow, they taught it systemically, order, and so on. And then at the end they did a little bit about bioethics, what disease. And he never forgave me for that. But I have no problem with people thinking people. All I can say is that what I've tried to do, and what the others have tried to do, is highlight some of the extraordinary adaptations that animals take to inhabit the niche. And all I can say to you is, you know where to find me. I'm in the zoology department. Fiona certainly know where to find me. So if you want any help with anything at any stage, please feel free to come and find me. So, happy Christmas to you all.